I'm going to talk about the state of Ethereum. I heard that people wanted to know about what's going on with Ethereum. It's my job to know what's going on with that all day as the Chief Strategy Officer of ConsenSys. And even I find it kind of hard to know everything that's going on because there's a lot. So I'm going to try to help people understand that. So who thinks they know all about Ethereum already and can explain in detail what it is? I'm just curious of the audience. Okay, not that many people. Okay, who's here to learn about all the deep stuff of public network Ethereum and what's going on with all the crazy gas crises and scalability and stuff like that? Okay, and who wants to know about how enterprises are using Ethereum? Okay, so half and half. Hopefully I'll have something for all of those camps of people. So when I say Ethereum, it's not just the second largest market cap cryptocurrency, which I think is what a lot of people think of it as. It's all of these things together. It's in a virtual machine that allows it to execute code. It's smart contracts, which is the name that we give to that code that runs on the virtual machine. It's the token, Ether, which is the fuel that we use to pay for that computation that runs on the Ethereum blockchain that is comprised of basically computers all over the world that make one logical computer, one big state machine, if you will. It's token standards like ERC20. About 95% of all the tokens that you see on CoinMarketCap or that you hear about being traded are actually ERC20 tokens, increasingly ERC223 tokens. And then finally, it's the decentralized applications that we run on that. One of the most popular that you've probably heard of is CryptoKitties. That's actually a 721 token. But all of these things together, taken together, is really what we think about when we think about Ethereum. There are parallel tracks going on right now. So this is a rough timeline of how Ethereum has developed. You know, late 2013, early 2014 is when Ethereum was being invented. It goes live in the summer of 2015. Around 2016 or so is that better? Whoa. Okay. Okay, good. Around 2016 or so is when enterprises really started to get deep into looking at this and asking the question of whether they can use this for benefiting their own business. Around 2017 is when, at ConsenSys, we decided to help, along with Microsoft, JP Morgan, Santander, a number of other startups, to found something called the Enterprise Ethereum Alliance, which is aimed at a number of things to help enterprises use Ethereum. I have a slide on this later, but it's the largest blockchain industry consortium. We have everyone from the big four, large accounting firms, to banks, to Microsoft in that organization. And what we've started doing is a parallel track. We've started creating a parallel track, not just for public Ethereum, although it's compatible with public Ethereum, to build something that's a specific version of Ethereum that is focused on enterprises that we think is actually the best trade-off of all these worlds. Let's talk about what Ethereum is right now. We estimate there are about 250,000 developers globally. Who's seen that weird clip of a Microsoft executive, Steve Ballmer, shouting, developers, developers, like 20 times on stage? You guys know what I'm talking about? Yeah. So this is why this is really important, right? Microsoft knew it was important. Everyone knows it's important. When you're choosing a platform to run your business on, you don't want some kind of proprietary small thing that there are only 50 developers or even 5,000 developers in the world that understand. You want something with hundreds of thousands of developers or millions of developers, right? When we estimate this, the last time we estimated the comparison, this is about 40 times the number of the next blockchain platform in terms of the people that are actively developing on it. Every month, there are about 30,000 new developers using our build platform. And so that's a good estimate for us. As I mentioned before, 95% of the tokens that you hear about that are trading on various exchanges are actually Ethereum-based tokens, meaning that they are built in a smart contract on Ethereum. And right now, as of today, it's about 50 billion in market cap of the Ether token itself. This is being used already by enterprises, right? This isn't just crazy crypto anarchists on the internet. These are companies like BHP Billiton, one of the largest oil and gas mining firms in the world. We help them to build a provenance tracking system to track all of their mineral deposits that they run sampling tests on. Santander, it's a huge bank. They use this to do some settlement inside of inside of their interbank exchanges. ING is using this for oil trading. JP Morgan, obviously, was a founding member of the Enterprise Ethereum Alliance as well. despite what might be said by other heads of JP Morgan. They've been very involved with this for a long time, and they realize that this has tremendous value for them. I also, as Amanda mentioned in the last panel as well, Dubai has decided that pretty much all government transactions that are possible to be run on blockchain need to be run on blockchain by 2020. And we're helping them realize that goal, and we're using Ethereum to do that. So this is something that has tremendous already existing enterprise applications. So I want to talk a little about why Ethereum is what it is, and some of the design choices that have been made here. So what do we really want when we are designing a blockchain? I would contend that there are three things. We want privacy, we want scalability, and we want to default to openness, right? The third one's a little controversial, and if you compare it to some of the other DLT technologies that exist, some of the more proprietary standards that exist that are not Ethereum, I think those aren't as open, and I think therefore have lower utility in the long run. I'll get to that later. But what you really want, what people are really saying when they try to build a private blockchain, or when they try to build an alternative blockchain with different methods that allow businesses to use it for something, what they really want, what they're really saying is we want privacy, then the security that comes along with it, because my chief risk officer told me that I need to have this, and my chief compliance officer told me I need to have this. That's fine, but I think Ethereum is in the process of realizing those. And then you want scalability. You want it to go faster, and I think we can also do that as well. So I want to talk about all those things today. So scalability. This is what Vitalik Buterin called the scalability trilemma. I don't know if you guys can see that very well. So we've got in the middle, so you have decentralization at the top, scalability and security. And so the conjecture is that you kind of have a trade-off between these things in the existing landscape, right? And in the middle, you have the compromise zone. And there are a bunch of technologies that have chosen to compromise this, chosen to compromise specifically decentralization in the interest of having things like scalability. So I would put, you can't really read it because I think it's warped a little bit, but I would put Hyperledger, I would put EOS, I would put Corda in that category that have sacrificed decentralization for scalability. And you have Ethereum and Bitcoin. That weird green thing is Bitcoin, all the way over on the left, that have maintained their decentralization, refused to go into the middle of the compromise zone. And at first glance, they've sacrificed a little bit of scalability. But I think what we're doing is solving for that right now, and I'll explain how we're doing that. There's some interesting points on there too, like the Voyager golden record is the perfect example of security. You can't really do much with it because it's just a gold record in space. But that's an example of the extremes at the perimeters of this triangle. On the right side too, you have serverless and public cloud, so things like AWS Lambda, Google Cloud Functions. These are things that don't have servers, but you can send functionality to, you can send computation to. I know some of the audience is gonna glaze over a little bit on some of this, but I wanna try to go deep into some of the technical stuff, but I'll keep that pretty small. So what we said, at ConsenSys and in the Ethereum, Enterprise Ethereum Alliance, is how can we get this scalability but still have decentralization? Still not have weird things where people can collude with each other and have governance problems and sacrifice the decentralization that we think is important. One take on this, so this is actually what EOS and BitShares use. One way that we've tried to achieve scalability in the blockchain world is delegated proof of stake. And what this means is that instead of having thousands of validators, tens of thousands of validators, miners, proof of stake participants, you've chosen a small group of participants, right? In the case of EOS, it's 21 block producers. So the idea is if one of these behaves incorrectly, one of these starts submitting false transactions or being sort of anti-social to the rest of the group, then you can vote to remove that block producer and it'll change. The problem is, in practicality, in BitShares, for instance, which was the first, I think, large DPoS implementation, less than 10% of all people vote, right? You end up with weird tragedies of the commons, like people leaving all the tokens on exchanges and leaving the exchanges to vote for them. You end up with EOS taking several days to launch, even though the project was technically launched, because they couldn't get enough of the participants to actually vote. You end up with the incentive to collude in circumstances. So, you end up with censoring transactions, which just happened, where 21 people decided that they wanted to censor a bunch of accounts. And that sounds pretty centralized. It's not necessarily something I'd want to send $1 billion over if I were sending $1 billion or a $5 billion transaction. It just has some kinks that need to be worked out. So this is why when Vitalik was inventing Ethereum, he considered and rejected DPoS. It's not that this is a new innovation. It was considered and rejected. And the reason is what I just said, but I think we can solve around that. So a better way to do it, I think, which is what we're doing in Ethereum world, is by separating the concept of L1 and L2 protocols. So Ethereum, the base chain of Ethereum, we consider an L1 protocol, meaning it needs to have high trust, high decentralization. I can send $1 billion transaction over and not think about it. I know it's going to complete. I know no one's going to censor it. I know no one is going to collude to steal my money or alter its behavior. This has some trade-offs, though. It needs to be a little bit slower. It needs to have high trust models. But what you can do is you can build protocols on top of that that are related to that underlying protocol. So what I can do is I can build, which this is basically what Plasma is, which I'll get to later. I can build essentially a side chain that has much faster network topology, it has much faster transaction times, thousands or tens of thousands of transactions per second, and I can relate that to the lower blockchain. I can resolve any dispute on that L2 chain in the L1 chain. Have I lost everyone? Does that make any sense? Anyone who thinks I'm crazy? Okay. No one, wow, okay. Okay, so we could build basically a DPoS system, and in fact, Loom Network has already done it in L2. And then if there's ever a problem with it, it can solve the problem by appealing mathematically to L1, to the high trust base layer of Ethereum, what everyone thinks of as Ethereum. The problem can resolve itself game theoretically by reaching back down to that lower layer that has the high trust that we're talking about. And this, I think, is one of the ways that we can achieve extremely high trust and extremely high scalability in Ethereum, and we don't end up conflating the sort of L2 and L1. I think some of the projects are, in our estimation, conflating those things. So here's solving the scalability trilemma. This is one example of how you could do this. I don't know if you guys can see, but the idea being things like AWS Lambda, things like the Azure cloud, things like OpenShift, which is an open cloud platform. What we can do is we can take Ethereum and we can connect that to these other service providers. So I can make a call that needs high computation. It needs a lot of CPU time, and I can just make a call over to something like Amazon Web Services to have that done. This is exactly the architecture of the enterprise version of Ethereum that our Pegasus team and the Enterprise Ethereum Alliance just standardized. So I'll get to a little bit more about that in a second, but privacy, one of the other things we really want here. JP Morgan invented Quorum. We eventually helped them a little bit with that, and this came out of some of the discussions and work within the Enterprise Ethereum Alliance. This allows private transactions on Ethereum. It's basically a modified version of Ethereum, but it's good enough for a small company like JP Morgan to send some transactions over it, and there's one model of how we can achieve privacy on Ethereum. There are a bunch of other ways we can do that. Some data can be stored off-chain. Some private transactions can occur like Quorum does. We have ZK snarks and ZK starks. Those are really esoteric, weird things, but you should check them up. ZK snarks is what Zcash is based on. That's what gives it its privacy in its transactions. ZK starks are a really new, cool thing that are 10 times faster than snarks and quantum resistant, and also have no setup time, which is the hard part about running Zcash. And so those are actually going to be integrated into the roadmap of Ethereum as well. And then finally, what I would argue is a default towards openness, right? When I think about platforms in the past that have not defaulted towards openness, in the face of the internet, which was an open standard, and allowed anyone to run what they want on it. At first, people just thought we wanted websites. Then we realized we wanted Snapchat. Now we realize we might want trillions of internet-connected IoT devices. We want this sort of open standard that allows people to do new, unforeseen things. When I think about the opposite of that, I think about things like this. These are the opposite of that, and I don't really want to be the opposite of that, right? I mean, these are closed, walled gardens that you could put things on. It had real utility, but you don't get the network effect of being connected in an open way to the rest of the infrastructure and the rest of the economy. You can't permissionlessly go add something to AOL. You couldn't to AOL or CompuServe. because it was a walled garden. And the thing that I would argue really caused the innovation of the internet, really kind of set the stage for that innovation, was the fact that anyone can just go on the internet and set up a web server and have people connect to them and start using their services. That's the vision of what we want Ethereum to be as well. We want an open, permissionless system, and we want to default there at all times if we can. And that's why, even though we're doing work in the Pegasus group and Enterprise Ethereum Alliance to make private versions of Ethereum that have high scalability, that have connections to things like the Azure cloud, we are always designing this so that we could one day flip a switch or one day build interoperability to the public network. And that's, I think, a flaw, in my opinion, of what some of the other architectures out there have failed to do. Let's talk about the enterprise a little bit. So this is a little bit of the groups that are in the Enterprise Ethereum Alliance. So we just passed 500 members, which is astounding. We have lots of governments. We have Intel, as I said, Big Four, Accenture, lots and lots of startups, UBS, banks. Like this is a pretty good list. If I had to choose sort of an index on the world of the biggest, most important companies, this wouldn't be a bad one. This would probably be just as good as the S&P to figure out what are the most important companies in the world. And then on the right here, I can zoom in on that a little bit. This is the Enterprise Ethereum reference architecture. This is what we have come up with, along with our partners in that Enterprise Ethereum Alliance, as a way to add all the functionality to Ethereum that we think enterprises need. So things like permissioning, things like trusted oracles, which is how you get trusted data into the blockchain to make decisions and smart contracts, things like configurable different types of encryption, things like private consensus algorithms, things like trusted execution environments, all the things that you might, your chief risk officer might raise his or her hand and say, like, wait, blockchain can't do that stuff. Actually, it can, and it does, and it's already being implemented right here. So I would urge everyone to go check out what's going on, even maybe have your organization join the Enterprise Ethereum Alliance if you're curious what the work is going on there. We have different working groups in lots of different industries like automotive, healthcare, insurance, et cetera. So something for everyone, and we're trying to make standards that allow everyone to use Ethereum for their purposes. All right, so here's the stuff that I said would be the up-to-the-minute weird stuff that's happening right now in Ethereum. This is the average gas price since December 2017 of Ethereum. So there's a giant spike. You guys can probably see it on the left, right in January. That is CryptoKitties. That was, I think, the first successful big high-throughput application that lots of people heard about on Ethereum, and it kind of clogged things up a little bit. On the right is actually very recently, and I'll describe a little bit what's happening there. This is CryptoKitties. I think it's great. You know, if you think back, when I think back to when I was a kid, the internet, I'm dating myself a little bit, but the internet was first coming out. People were first starting to play games on it, and it was kind of slow. It kind of sucked. And Ethereum, right now, I would analogize to that, right? This is a very high throughput set of transactions, started to show the limits of the capabilities of the network, which is exactly why we need to build the solutions that I'm talking about. This is Vitalik commenting on what's happening right now. So those second spikes that were on the right, this is Vitalik saying, hey guys, this is pretty weird. Wow, he says. $15 million is how much someone paid, or some groups of people paid, to send all these sort of spam transactions to the network. It appears that part of this was due to an exchange called Fcoin, which was doing this sort of weirdly designed giveaway where they would give away all these tokens to people, and that caused these airdrops to happen on the network, which used up a whole bunch of the capacity of the gas of the network, and it slowed the thing down. But it also appears, some people believe that it was some competitors of Ethereum maybe, but it also appears that someone was spending millions of dollars, or maybe just several groups were, to basically airdrop, to give away all these tokens that don't do anything, actually. They don't really have websites, or they have very kind of sparse websites that don't actually seem to have a team or a project in them. But they're just sending these tokens all over. And this is eating up about half the capacity of the network, or it was until about a week or so ago. So that's some weird stuff that's happening right now. 75 Lambos worth. So this is not a person who made a mistake. This is someone doing this actively. So interesting. So what does the future of Ethereum look like? And this is where I'm going to get into a little bit of the weirder, more developer-y stuff for the people who want to know about that. I would break the main innovations happening in the efforts of scaling on Ethereum into 3 categories, basically: Casper, sharding, and plasma. So Casper is the name given to, it's actually the full name for the current version is Casper FFG, which stands for the Casper Friendly Finality Gadget. This represents the work in the Ethereum Foundation moving towards proof of stake. People know what proof of stake is? Should I describe what that is? So proof of work is mining, right? People need to do something really hard, namely in Bitcoin or Ethereum or whatever as it currently stands, you need to do a really hard math problem over and over again to basically to limit the rate at which these things are produced, to limit the rate at which Bitcoins are awarded to the miners, to limit the rate at which Ether is awarded to the miners, and to cause it to be very difficult to sort of fake it, right? That's how we achieve security in the current proof of work mechanism. Proof of stake is the idea that instead of having a whole bunch of computers doing a really hard math problem to mine and to confirm the transactions, instead what we have is a whole bunch of parties that are temporarily trusted and they have a stake. So sort of like they post a bond, like say I post $1 million, and if I go and I behave poorly by not confirming the transactions correctly, then I lose my $1 million. That's basically the proof of stake. I have something at stake, so it's a game theoretic guarantee that I'm going to behave well, right? And over time, if I keep doing that, I'm just going to run out of money, and it's financially impossible to make the network not behave correctly. That's the idea of proof of stake. Casper, I'm going to describe a little bit more about, but that's being worked on right now. It's already sort of in testing on Ethereum. It'll be rolling out not that long from now. Sharding is the idea that you can break the network up into smaller pieces, right? So instead of having one big monolithic Ethereum that everyone's mining on, everyone's confirming the same transactions, instead we might have 100, I think currently there's about 4,096 shards being considered in the design, meaning that there will be 4,000 different mini Ethereums for every 5 seconds that then collapse into the larger Ethereum over and over again. And that allows those smaller sort of shards, as they call them, like a shard of glass, those shards to behave much more quickly than the whole network needing to be in synchronous behavior. And finally, we have Plasma. Plasma is basically the idea that you can build a side blockchain, essentially, to Ethereum that has its own properties that can be much faster than Ethereum itself, and then that blockchain likely is temporary and can collapse back down into the main chain. So it's sort of like, you know, I have the blocks of the main Ethereum blockchain, I temporarily put some Ether in a smart contract, that creates a new version of Ethereum off to the side that goes fast, does a whole bunch of transactions between a limited number of participants, and then it collapses back down, and the Ether that was in the original smart contract gets distributed to the original participants. Or maybe a validator that was putting up that sidechain. I know that sounds really complicated, but I think it'll allow those 3 things combined, I think can easily allow Ethereum to scale to tens of thousands of transactions per second in the public version. So here's a general roadmap of what's happening in the Ethereum world. We've got Plasma, which is what I just described. We have Raiden, which is state channels. It's kind of peer-to-peer sending of transactions. That's you've probably seen in Bitcoin. They've recently launched the Lightning Network, which similar idea, but in Ethereum we have to do much more complicated things than just send tokens. We have to send all kinds of logical values to each other, so it's a little more complicated. So layer 1 is what I was talking about. Those are layer 2 protocols. Layer 1 is what I described as the base, the main chain of Ethereum, what everyone thinks about. So we're getting quadratic sharding. That's happening right now. That's what Casper is. Cross-shard transactions. This is over time, over the next few years probably. Eventually we'll get to super quadratic sharding and get higher than thousands of transactions per second. So proof of stake is also happening. It's already on the testnet. Casper Friendly Finality Gadget. This is basically a proof of stake system. It's a little bit like delegated proof of stake, which I had some critical comments of earlier. However, the difference is all of the validators, all of the stakers are randomized, actually. So Casper, what it does is it chooses a random subset of all the people, so the people can't know in the future what's going to happen or who's going to be the validator, and therefore they can't collude and they can't do anything negative to the network. So it ends up achieving the way that we basically have shards elected, and also the way that we have finality. And so that's a little esoteric, but finality basically means right now you don't know exactly when the next Ethereum block's going to happen because it's whoever mines it, right? Casper will allow us to choose every 5 seconds. There's definitely a set of validators that are chosen, and we'll have regular 5-second blocks. And then we know that those blocks are final, and that's why it's called the friendly finality gadget. Also working on adding eWASM, which is, if anyone knows what WASM is, it's WebAssembly. This is a standard that's used across different browsers. It's used in the platform that Google Chrome is made out of. It's used, and also some other browsers. It's used in pretty much every major browser right now, and it's being elected as a standard for a virtual machine across the internet right now. It's kind of like the Java virtual machine or the Ethereum virtual machine. This is a more standardized thing that is a virtual computer that we can conceptually think of as Ethereum, that'll allow more developers to understand it, more platforms to support it, et cetera. So we're moving probably to a subset of the WASM WebAssembly language. And then finally, these other things like account abstraction, custom execution engines, et cetera. This is the kind of roadmap of what's happening over the next 2 to 3 years in Ethereum. Then I'll get into a little more detail. I'll just go quickly through this because I'm almost out of time, but Ethereum 2.0 is what a lot of people are calling the next generation of these technologies. So one of those is the proof of stake overlay, going from proof of work, which I described, to this idea of finality, 5-second blocks, a beacon chain that selects those random producers, those random validators that I described, and then eventually we'll go to full Casper, which is a different proof of stake model, sort of building a proof of stake chain alongside the main Ethereum chain, and then eventually switching over to that proof of stake chain once we're all comfortable with how it's working. There will also be changes to concurrency, right? So right now, all the nodes on Ethereum have to all agree in the public version of Ethereum at any given time what's happening. This runs, for computer scientists, nerds, it runs at big O of C, and we'll move to this sharded style that moves at big O of C squared. Basically means it's a multiple faster, or it's an exponent faster, exponentially faster than Ethereum 1.0. So this is a little bit what that looks like. Hopefully this can explain a little bit. So that yellow chain on the top is the main chain. This is basically what you think of it as Ethereum right now. The beacon chain is the stuff I was saying generates those random numbers. This is what Casper is. It's generating who are the validators, essentially. There are these little temporary shard chains that are all connected to those validators, or they're chosen by that beacon chain and those validators. And then there's the virtual machine. This is like the computer that is Ethereum that runs on top of that. So we're moving to that, basically. We're going to have different state transitions. I already described this mostly. Right now, the EVM, while beautiful and amazing, it has some limitations. So I think we'll have lots more of Steve Ballmer's developers if we have eWASM. So that's happening, it seems. And then finally, slashing. So this is a different concept of how to encourage the game theoretic behavior that you want in the network. The Ethereum 1.0 is basically the idea that you get a mining reward, and that's why you produce and give this public good to the network, because you want to be rewarded for it. Ethereum 2.0 is going to add actually some negative kind of inverse rewards or punishments for doing things poorly. So you get slashed, essentially. That has it's not literally slashed. It has some weird Vitalik origins in a video game, I believe is why it's called that. But it basically means you get penalized for behaving poorly on the network. So those are all pretty big changes to Ethereum. I think it'll allow us to get everything at that trilemma triangle without really sacrificing anything. And please ask me if you're curious how that's the case. We're also charging rent, maybe. This is controversial. I don't know if this will happen for storage, but that's it. Thank you so much.